Good day, everyone. I'm Arvin Enriquez, your subject teacher in General Mathematics. With this video lesson, we're going to discuss the topic exponential functions, equations, and inequalities under your General Mathematics from Quarter 1, Module 17. Our lesson objectives. At the end of this video lesson, you are expected to distinguish logarithmic function, logarithmic equation, and logarithmic inequality. Formulate own examples of exponential functions, equations, and inequalities. Let us now deal with this activity. Spot the similarity and difference. So below are three expressions. Observe them and spot their similarities and differences. So for letter A, it's 3 raised to x minus 2 is equal to 81. Your B, your y is equal to 4 raised to x. And for letter C, your 2 raised to x greater than or equal to 32. So I'm going to give you some questions wherein we can check if there's a similarity or difference between these three expressions here. So the first question is that, or it's simply this will serve as your guide in looking for the similarities and differences between these three expressions. So first question, so what is the similarity of A, B, and C? So you observe. So what is the similarity of A, B, and C? Next question. What is the similarity of A and C? Third, how do A and C differ from B? Fourth, how are A and B similar to each other? So what is the similarities between your A and B? The next question is that how do A and B differ from C? So you look for A and C. So what is the difference between A and C? And for 6, can you recall which among them is an exponential functions? So last time we're done with your exponential function. So 7, which among the three is our exponential expressions? So last time we're done with your exponential functions wherein it it can be represented through a form of f of x is equal to b raised to x, wherein we can rewrite this one as y is equal to b raised to x, where your b is greater than 0 and not equal to 1. As long that your b is not greater than 0 and not equal to 1, then that's that's the first consideration that we need to look for. Second consideration is that there is an involvement of your x variable in your exponent, or there is an involvement of variable in your exponent to your base, which is a whole number or a constant, I mean. So I mean to say that your base is a number which is greater than to 0 and not equal to 1. So again, in an exponential function, you need to satisfy that your b is greater than 0 and your b is not equal to 1. Then your exponent, there should be an involvement of your variable. Now, so if we try to look at these three expressions here, As we can see, or as you notice, no, all the three givens are expressions involving variables. Yes, as the exponent. So let's see, no. In letter A, these are expression with an exponent, no, involving a variable x. So as you can see here, so there's an exponent x. Same thing with letter C. So there's an involving variable as the exponent. Next, to your A and C. Yes, but involves one variable only. No? As you can see, A and C has only one variable involved to them. So there is no such thing as Y variable in your A and C. So I mean to say the similarity between your A and C is that there is only one variable involved to them, and that is your X variable. So while B involves the relationship, no, between two variables. So if you try to recall the concept or definition of your exponential function, your letter B is a good example of an exponential function. I mean, because your base 4 is greater than 0, then 4, or your base 4 now, is not equal to 1. So I mean to say the first condition, no, in looking for, or if we're asked to determine if the given is an exponential function, then we satisfy the first condition that your b is greater than 0 and not equal to 1. And next thing to do is to check if the exponent has a variable x, or there is an involvement of your variable x. So as you can see in your letter B, there is an involvement of your variable x in your exponent. So your letter B now is a good example of exponential function. So nevertheless, no, A and B both use an equal sign. B, however, it contains an inequality symbol. No? Your letter C, I mean, no, use an inequality symbol. So both your A and B use an equality sign. So there is an equal sign between the right side and left side of your expressions. Unlike in your letter C, we use an equality sign, so that is greater than or equal to. No? So we simply use inequality in your letter C. Now, let's try to recall that B as an is a good example of exponential function. Yes, it is, no, because we satisfied the two consideration that we are looking for, no, before we conclude that this given is a good example of an exponential function. So here, no, as you can see, that there is a y and x variable in your letter B, meaning to say there's an involvement of your dependent variable y and there's an independent variable x. So the value of y will be always be dependent, no, on the variable on the value that we put, no, as a value of your x variable here. So meaning to say that your x is your independent variable, then your y is your dependent variable. So nevertheless, again, no, all three are exponential expressions. So these three are exponential expressions. Yes, it is, no, including A and C. So these three are good example of exponential expression. It is so since all are expressions, no, with a variable and use an exponent. So as long that no, as long that there is a part on this expression, no, that your b or your base is greater than 0 and not equal to 1, and there's an involvement, no, of a variable x as an exponent of this b or base, no, then the given is an exponential expressions. Now, in this case, no, all these three expressions has that component. So there is a part of, of these three expressions wherein there is a base which is greater than 0 and not equal to 1, and there is an exponent attached to it, and there's an involvement of x variable on each of the exponent being attached to our base here. That's why we consider these three expressions as a good example of an exponential expressions. So let's deal now with the formal definition of your exponential function, exponential equation, and exponential inequality. First, let's deal with your exponential function. So it's a function involving exponential expression, showing a relationship between the independent variable x and dependent variable y, or f of x. Why is it we use or there? Because we simply replace your f of x by simply using your y, or we can rewrite a certain, no, or if there's a given functions, no, if you're asked to rewrite, we can rewrite your f of x by simply using your y, or we can replace your f of x, I mean, no, by simply using your y. So we can rewrite this f of x is equal to 2 raised to x plus 3 as y is equal to 2 raised to x plus 3. So as long that there's an involvement, first consideration in your exponential function, you should check if there is an involvement of your independent variable x and dependent variable y. And please do check next is if there is a part of it that there is a base and an exponent of variable x. No? You should look for the location of your variable y and variable x. That your variable x in an exponential function should be an exponent, no, attached to your base which is greater than 0 and not equal to 1. So that will be your second consideration. Next thing to do is to check, no, again, no, if there's a y variable. There should be a y and x variables, no, in this kind of function. That x variable will be a part of your exponent, no, as the exponent, no, in your base b, which is greater than 0 and not equal to 1. And it's the same thing that we can replace f of x by simply using your y. That's why here, there's a good example of an exponential function that your f of x is equal to 2 raised to x plus 3. So as you can see, there's an f of x here, no? Based on our definition, no, we can use your y to replace your f of x here. So we can write this one as y is equal to 2 raised to x plus 3. So your 2 here is greater than 0. Then 2 is not equal to 1 in reality because 2 is greater than 1 in reality. So therefore, there are two variables involved here. X as your exponent to your base 2, wherein your 2 is greater than 0 and your 2 is not equal to 1. So we satisfied what your given conditions, no? So therefore, f of x is equal to 2 raised to x plus 3 is a good example of an exponential function. So let's check again, no? Our next example, I mean, that y is equal to 10 raised to 2x. So as you can see here, that your 10 as your base is greater than 0 in reality. Then your 10 here is not equal to 1, definitely, because 10 is greater than 1. So there is a difference between 10 and 0, 10 and 1, no, which is equal to 9. Now, since there is an involvement of your y here, that will serve, that will tell you, no, that will show you, or that will represent, no, that this one is a function. Now, we need to check if this is an exponential function by simply looking at the exponent of your base 10, if there is an involvement of your x variable there. So since there is an involvement of x variable in your exponent here that is being attached to your 10 as your base, then this one is a good example, no? Again, it's a good example of an exponential function because you satisfied both your given conditions. Before we conclude that these given functions are exponential function. Now, let's move forward, no, with an exponential equation. So, it's an equation involving exponential expression that can be solved for all x values satisfying the equation. So here, as long that there is an exponential expression or there is a part of this equation that there is a base that is greater than 0 and less than and not equal to 1, and there's an involvement of x variable here, as you can see in this, in the first, in the first example, that 1 to 1 is equal to 11 raised to x, no? Even if one side of your equation here has a base that is greater than 0 and not equal to 1 and has an exponent uh, of variable x here being attached as an exponent of your base, then this example is a good example of an exponential equation as long that there's an involvement of exponential expression. Plus the thing that the symbol, no, or the sign between your left side and your right side is equal sign. So you need to check first, no, if the symbol or the sign between the left side and right side of the given equation or inequality, for example, if that's the equal sign, then the given is an exponential equation. If if the symbol or sign between your left side and right side, no, shows inequality, meaning to say that the given is an exponential inequality. So that's how we uh, check, no, if the given is an exponential equation and exponential inequality. So for the next example for these exponential equations, no, so it can be both sides of your equation can be both exponential expression. So it is not the case, no? It can be one of them or both of them. So we need to check. So this is a good example of exponential expression. Why? Because 3 is greater than 0 and not equal to 1. Same thing with 9. And there's an involvement in your exponent using your variable x there as your exponent attached to your bases here. No? So meaning to say that this one is a good example of exponential equation. So for your exponential inequality, is an inequality showing inequality involving exponential expression that can be solved for all x values satisfying the inequality. So what is the difference now between your exponential equation and inequality is that the symbol, no, or the sign between the left side and the right side of your equation or your inequality. As long that the symbol between your left side and right side is equal sign, and there's only one variable involved to it, which is your x, that will serve as the exponent, no, of your base. If that is equal sign, then that will be your exponential equation. If that is, if that sign, no, shows inequality, so it can be less than, greater than, less than or equal to, greater than or equal to. If you see that symbols or signs, no, it shows inequality. Meaning to say there is no such thing that we can conclude that this given is also an equation. So it's always dependent, no, on the symbols being uh, on the symbols that we see, no, on the given equations or inequality. Now, if that is inequality, the symbol between your left side and right side shows inequality, meaning to say there is no such thing as equal. There's always not equal to, no? It can be it can be your left side is greater than your right side, or it can be less than or equal to. Now, you need to check if there is an involvement of your exponential expression. Again, you need to check. It can be one side or both your left and right side, no, can be an exponential expression. But in this example, as you can see, this is a good example of exponential expression. Your right side is an exponential expression. Then this is a good example of a whole number that has an exponent of 1/3. Here, in this case, in this scenario, same thing, that your left side is an exponential expression. Then this will be a decimal. So regardless, no, if that is a decimal or a whole number with an exponent of fraction, as long that there is an exponential expression there and there's a symbol between the left side and right side of this given, then we can conclude, no, that this can be an exponential equation or inequality. It depends on the symbols, no, or signs between your left side and your right side. So that's how we determine if the given is an exponential function, exponential equation, and exponential inequality. So for your activity, so where do they belong? So you're just simply classify them, no? If they are belong to exponential function, exponential equation, exponential inequality, and none of these. So there are situations wherein the given will not fall in your exponential function, exponential equation, and inequality. Then you need to list down here, no, under the column that will represent the none of these. So again, below is a list of exponential expressions. Classify each as to whether it is an exponential function, equation, inequality, or does not belong to any of these three. So again, you need to put, again, in your Catleya, and you need to put the module number and the activity number. Then you need to classify. What you need to do in this activity is only to classify the given exponential expression, whether they fall here in your exponential function, exponential equation, exponential inequality, or none of these. Or meaning to say, they did not fall, no, between your exponential function, equation, and inequality. So thanks for watching. Please do like, comment, and share, and subscribe.